Here in this video, we are solving two problems of NEET 2017 and 18, both based on interference concept and in particular Young's double slit experiment. They are simple problems. Let us see what is the first problem is. In a Young's double slit experiment, the separation between the between the slits is 2 mm, wavelength lambda is used, given the value 5896. Distance between the screen and slits is also given. It is found that the angular fringe width is. So, how does the experiment look like? There will be a source, monochromatic source, that passes the waves towards a double slit. Now, each slit acts like a source. Distance between the two small slits is small d. We capture the resultant on a screen. This is our screen. Distance between the screen and slit is capital D. We use a wave. That wave will have a certain wavelength lambda, and on the screen there will be a pattern of bright and dark fringes, that's called interference pattern. Each fringe will have a certain width called something like fringe width. We can write the formula for the fringe width beta as is derived lambda into capital D by small d. But what is being said here is the angular fringe width. Beta by capital D is called theta, angular fringe width. So, angular fringe width theta equal to lambda by small d. That is what is given for you, 0.2. To increase the fringe width to 0.21 with same lambda and capital D, the separation between the slits has to be changed as what? He said lambda is kept constant. So, theta is inversely proportional to distance between the slits, independent of capital D, though it is given as capital D same, that does not require because it is not, fringe width depends on capital D, but angular fringe width does not depends on capital D, it only depends on small d. So, I can write a formula theta 1 by theta 2 equal to angular fringe width 2, 1 by 2 equal to d2 by d1, where d is the distance between the slits. Theta 1 is 0.20 by 0.21, d2 we have to find out. d1 distance between the slits is given as 2 millimeter in millimeter. So, 20 by 21 equal to d2 by 2, that implies 21 d2 equal to 20 into 2 is 40. d2 equal to 40 by 21, as given data is in millimeters. Your answer also will be in millimeters. It is obvious that if it is 40 by 20, it could have been 2. It is just little less than 2, because it is 21. And in that calculate, that will be 1.9 millimeter. You calculate, you will get the same, right? That is how we solve this first question. Let us see what the second question is. In a Young's double slit experiment is performed in air and then in a medium other than air. It is found that the 8th bright fringe in the medium lies with the 5th dark fringe lies in air. 8th bright fringe of the medium is 5th dark fringe in the air. What is the refractive index of the medium? So, for example, first of all, for bright spot, path difference delta x equal to n lambda in air. For a dark spot, path difference delta x equal to 2n minus 1 of lambda by 2. Be careful, here n starts from 0, 1, 2, 3 onwards. Here n starts from 1 onwards, 1, 2, 3 onwards, right? So, it is given that 8th bright in medium equal to 5th dark in air. So, n lambda in that medium equal to 2n dash minus 1 of lambda in air by 2, where 8th bright lambda in the medium is lambda by refractive index of that medium. Refractive index in any medium decreases when compared with the refractive index of the air, equal to fifth dark, that is it not fifth dark, lambda by 2. This lambda and lambda will cancel. So 8 by mu equal to 10 minus 1, 9 by 2. That implies refractive index is 16. Refractive index is 16 by 9. So 9 ones are 9 and 7 is there. 9 sevens are 63 onwards. So it's close to 1.78. That's how we solve this problem. Thank you for watching.